In this episode of FUM0104 machining, we are dealing with grinding wheels for my bench grinder. It originally had some really bad, not really bad, but I don't like these, the wheels in here, the table. So I have purchased new wheels. Well, new is a very relative thing, let's see what happens here. Well, here are the old and new wheels. This is was sitting on the left side. It's supposed to be a coarse wheel, and it is, but well, I have used this quite little, and it's still lost something like 5 millimeters of its diameter already. So this means that the binding on this wheel is very weak, and it will, of course when it behaves like that, it will spread dust all over the place, and not very good thing. But on the other hand, it will also grind well. So if it would be harder, it would not grind so well. But I don't need that kind of, I don't remove a lot of material in my grinding wheel. So this one is probably too weak a binding. It's a good general feel. It's as you can see, it's white. It means it's aluminium oxide. On the right side there was this green wheel, which is even weaker. It's spreading green dust everywhere when you grind with this one. You are supposed to be able to grind carbide with this one because it's silicon carbide, but yeah, you are, but it's still not very, how would I say it? Well, it's spreading so much dust everywhere that it's unreal. The mat under my grinding machine, when I used it once, was green of this dust already. So no way I would use it in my workshop. So these are out, furthermore, they are Makita branded, but there is, if you read this, they are made in China. Okay. So the new wheels, for this coarse side, I found from the local dealer here a wheel which is a little bit wider. So these are 19 millimeters, but this one is 25. And it is it's aluminium oxide, but this time it is ruby. And the binding is very tight. You can read here that it is, for the first, the grain size is 80. It's on the finer side. Grade, and this is how hard it is bind together, it's P. That's on the harder side. So this one, if you want to dress this wheel, it will be laborious, but on the other hand, when you use it, it won't spread a lot of dust around. Okay, it might become a problem sometimes if you want to remove a lot of material, but I believe this is better for me than this old one. So this one probably will serve me quite well. And for the other side, for the silicon carbide wheel, we have, it's actually made in Russia. This came all the way from Ukraine, and this is CBN. It's borazone, as they say it, but it's cubic boron nitrate. And it is actually, this one is 20 millimeters in white, opposing to 19, it's okay, and this is quite fine actually. Can I see it somewhere here? Oh yeah, maybe, maybe not. But it's anyway, it's a good replacement. One thing that you need to take care of when you are replacing wheels like this is how fast they spin. This machine is 40 meters per second and 3,450 revolutions per minute. So these their margins must exceed these really. So this one is rated by hand, which is now here, to 3,800 revolutions per second. Okay, it exceeds it, can be used, and 40 meters per second. Okay, that's a really good substitute. Then this one says 4,700 revolutions per second. It's here, and 50 meters per second. You can read here. I will show larger images of this. So this one, well, it's my grinding machine. The bench grinder is a little bit slow for this one, but it should go well. Okay, so that's one thing. You have to check that these can exceed the ratings of your bench grinder. If you there is a danger of wheel explosion if this has not been exceeded. Okay, another thing, before you install new wheels into your machine is to do a ring test. You take the wheel like this on your finger and then you tap 4 sides of it. Listen. You should get equal sound everywhere. Then you turn it 45 degrees, 90 degrees, sorry, and then you kick it again. Okay, this sounds good. And then I do the same for the new candidate of this one. Well, it sounds good. Yeah, sounds good. And the old wheels had a very different sound. Actually, this is because they are so soft. It's lower, the pitch is lower. And same applies to that one as well. Now, if you cannot hear this ringing sound, it's an indication that you shouldn't use the wheel. Unfortunately, I don't have any broken wheels here that I could show you how does it sound, and I don't want to break these. Okay, that's one thing. The next thing when you install these is to check that the hole here, this one is actually, these are, I will check that one. Wait a minute. Yeah, 16 millimeters. And I have noticed that this hole is 1 millimeter too large. It's 17. So we need to put something there that it will go there. And this one you can see by eye that it's already too big. Actually you can read it here. It's 32 millimeters. Oh well, you have to do something here. So for this one I will be using copper foil. I cut a strip from the side and roll it, and well, we need to compensate for 1 millimeter, we need 5 turns, I believe. This is a 0.1 millimeter thick copper film or whatever. And for that one we need to do a ring here in the middle. I will make it out of steel, but I will also make it a little bit undersized and put some copper there, because I don't like the idea of having steel in direct contact with your wheel. Furthermore, uh, these labels here, it states here that save the wafer. It means that you shouldn't peel these off. If you do, because when you put this into your grinder, there will be two discs. I will show you. Like these. They come here, and it's squeezed in between. And this one actually, if there are any, it's not a good idea to have steel and your wheel in direct contact with each other. The purpose of this is to increase friction between these and also get some cushion between these washers and the wheel. And since this one doesn't have that, we need to make a wafer like this for this one on both sides. So I will now install this wheel first. It's a simple task. Just cut something from here, and then I will put it on place, and well, after that we will go on with this one, and we will go into with our lathe. This I will use this piece of some mishap. I had this piece of metal which is really good. I can use that one for this, and then I really make it a little bit smaller so that we can put some copper in between there. And then I make the wafers here, both sides, and there you are. So let's go on with this. Okay, now I measured this hole one more time, and it's a little bit under 17 millimeters. So we probably need only 4 turns, but of this copper wire. But it needs to be 25 millimeters wide. So I have here 25 millimeters. I just mark it here like this. This is copper, so there becomes those little dots quite easily. Like that. This doesn't need to be exact. And now, well, I have these, they look like a toy, but these are made by Fiskars, the Finnish company, and these are really good ones. I have had these scissors for more than, let's say 15 years, and they have been serving me really well. And you don't generally need to sharpen these. Well, okay, here we have it. It's probably a little bit longer or wider than 25 millimeters, but on the other hand there is room. Then I take a round pin from here. Let's see if I have a good one. Without any, that one is good. Yeah, these are high-speed steel pins or something really hard material, I don't know. And I do like, I put it there and then I just draw this like that. This will flatten out any burr or anything like that in there. I do this for both sides. Like that, and one more time. There you are. And now it's quite flat. And then I take the end away, try to make it perpendicular. And then, now, since this is 16 or 17 millimeters, we need something that is near that one. Under, but near. A round object. Well, this one looks well, Okay, maybe. And then I just roll this around here, like this. It will spring, and this one you don't need, well, you just do it like this, and there you go. There is probably more than enough here now. Next thing to do here is to put it on top of the shaft and then count the layers. That's something. That one I will now do. This goes into this hole here, and it's on top of the shaft, and it's taking up the place in between. And yeah, so 4 turns for that one. So it should be quite near what we need. I will count the layers on the bench grinder of the camera. I did do the counting, and now I have a marking here which is 4 rounds, and now I'll just cut it off a little bit shorter than that one, because I don't want to have layers on the excess layer. So what I did, I just put this on top of the shaft, and then it was like, can I reproduce the thing? Yeah, it was like this, and then I counted. It's really easy to do. But now we should have it quite there. And then let me replace the camera so we can see how I put this in place. And yeah, this is the left side of the grinder. Now what we need to do is to see that everything is clean. I cleaned this already. And then you have these washers. The other one has a slot like that. Yeah. The other one doesn't. And there is this spring tap board inside the shaft. I don't like the idea, but yeah, what can you do? You buy a Chinese bench grinder, so you get things like that. Okay, so it goes down there, and as you can see, there is a recess. So that was the reason why this wasn't. Why we didn't need to. Why we can. Why this length is not so critical. And then I just put it there, very gently, rotate it, and as you can see, there it is. Let's see how to get it right there. Okay, there you are. Next is the wheel itself, this one, and now we put it there. And well, you don't want to drop this one, do you? There you are. Now, it's there. And I believe these wheels are, have a little bit of slope like this. This means that you shouldn't tighten them up at first quite tight. It will actually, and this is, well, I prepared this one. There is a reason why I took off with file the corners out of this. Well, this is a left hand thread here. Well, it's not straight at all. It's very hard to get straight. Well, That's the straightest I can do. And this was left hand thread, so there is a nut on the other side, flats. Wait a minute, there you are. So this side didn't have the flats, so this one should be installed first. And this was left-handed, so, and you don't tighten it too much, just a little bit, because it will tighten itself. Well, and it didn't move. Okay. Now I will try it out. And when you try these things out the first time, you don't want to be in this region. Because if it explodes, it doesn't explode that way or this way, it will explode this way. Well, this will be now. I just want to see whether this wheel vibrates. Or it doesn't vibrate. Let's see. Well, it's okay. At least the grinder doesn't start running around. Okay, so that side is now otherwise okay, but we need to put the cover on. And now, when it now stops, and because I'm going to work with it, I'm taking out the electrical connection. Stop. Yeah. So, there is this cover. Well, and I rounded the edges of this because I tried it before. And if you can see, maybe you can see it, it was touching this plate because it's wider. But now, since I only needed to file the corners off, and after that it was, yeah. And here you can see 40 meters per second, and on the back side in the other plate you can read that the revolutions. This goes here, and then, and it is really a bad idea to use this type of grinders without the seals. These just must be in place, and you should attach these quite well. These are M10 bolts. Yes, and I cleaned, while it was open, I cleaned it up there inside, so yeah, there was quite a lot of, let's see, yeah, it spins freely. The earlier one was scraping inside there, not a very good thing. So these should be tight enough not to come loose by themselves. So now this side is now ready. Well, yeah. Okay, next thing is to deal with the other side. This one is a little bit more complex. I need to go into the lathe and make a piece there. Furthermore, well, I already did this one. This is wide enough to accommodate that one. This should be made 1 millimeter larger, this hole my way. So we should take off 1 millimeter from there. Well, that's quite easy to do, just file it. This is aluminium, so not a big deal. So, I already dialed this piece in, faced it, and I have started to drill it with a 15 millimeter drill. This one will not be straight. It always, when you use your drill, it will not become a straight hole. It's always somewhat round. And in this case I want to have it really straight, because this one dictates how well the wheel is centered in the grinder. And I don't want, actually I would like to have a zero blade there, but this I believe cannot be achieved, so maybe we can settle with a little bit less accuracy. Well, what I will do here, I will first drill it 15 millimeters. After that I will bore it to something like 15.8 millimeters, and then finally ream it to 16 millimeters with this one. And well, let's drill. So there you go. And as you can see, it wobbles quite a lot. Next step, clean up the mess. Oh, these are a little bit hot. Ow. Okay. And now, well, one thing to always when you do this, because these are sticking out quite a lot. And actually, if I go under there, this will actually hit like that. So I need to be extra careful not to do that. Oh yeah, okay. Now boring. This is my boring bar. Is the insert? Yes, it's in good condition. And it reaches all the way through. Nice. And now I need to be really sure that we have room to do this. Yes, we do. And the jaws don't hit anything. I cannot possibly go there. Okay. Now we need a lot more speed here. And now I just touch here. There you are. And well, let's take something like 0.25 millimeters, and let's see how this looks like. Well, it works well. There you are. The surface finish is poor. It's horrible actually. So yeah, okay. This is now done. And now the next thing is to ream it. Okay, there we go. And reaming needs a lot of oil for the first. Like that. And then we go. And you do it slowly. Yeah, there you go. We are through. I will, okay. 116mm hole. Should be very good finish, and it should be round, and it should, yeah. looks really nice. These things have a recess here, backside, and the recess is 2 millimeters. So, if we make it 3 millimeters wider, it should easily accommodate there in between and be wider than the wheel. So 23 millimeters lengthwise, plus 5 millimeters for parting. Well, that's actually quite near 30. Do we have 30 millimeters here? No, we don't. Ah! Do we have, how much do we have actually? We have 28 millimeters, so we need to put the stop really near the jaws. Then we recheck it, that it is in the correct place. Yeah, okay. And then we need 32 millimeters, that's the minimum we need here. 35, this is 35, so we have enough material here. Okay. Well, we need to take a lot of cuts here. I will place this one under here. Let's see if it goes well. Yes, it does. What this does, it prevents the chips going in between there, my stop. Oh, I don't like that. Okay. Okay. So this, and then the speed. This time we can use the high gear, I believe, with gear. Okay. Let's touch it first. There you are. I zero this one so I know about where we are. So, I just take cuts, something like 1 millimeter at a time. Let's see how this looks like. This is better. Well, the chips are, I don't like those. Not very good. Long chips like that, not a good thing. Now it's 34. I can zero this one. 34. Let's take 1 millimeter more. So it becomes 33. I'm changing the speed to avoid a chatter, and it works really nice. There you are. Well, we got a little bit shattered there, but not too much. Now it should be 33. And it is. So, well, it's not too warm. And now of the camera, I will, oh, these strings are really horrible. Oh, what is this steel? Wow, this is a mystery metal, and really it is. So yes, we will I will now measure the actual hole size of the wheel, so we can make this the correct size. Let's measure the hole here. I have this snap gauge. Well, I know this is abrasive, and well, I don't like this operation, measuring abrasives with snap gauges. Okay, let's see now how much this is. Just gently feel it. There it is. Seems to be 0.05 of a millimeter oversize. And then take another direction. Oh, this is a little bit horrible. This is not easy to measure. Okay, this is also 0.05 of a millimeter. Then let's take the third one. If I get equal reading here, so then I can assume it is 0.05 of a millimeter oversize. And yes, I'm getting that one. So it's 0.05 of a millimeter oversize. So what this means, we need to, it's 32.05 millimeters. So, and if I want to put this in between, this is 0.1 millimeters, so I need to make that piece there 31.8 otherwise, but since this is 0.05 of a, well, I make it 31.8, it should be 31.85, but maybe I make it 31.83 maybe, just to accommodate some things around here. It might not be fully equal everywhere, and because this is actually, well, it might not be that accurate, but well, let's see. I will now go to the lathe one more time and then finish that piece there. Back to the lathe, and now let's measure this one, where we actually here. So it's 32.98. So we can take out 1 millimeter easily here now. So let's take 1 millimeter. Okay. Let's measure it now. So it's 32.5. So we actually, how did we end up? Is there? It's clean, because it should be exactly 1 millimeter. No, it's still 32.5. So if we take, we need to take 2/10 of a millimeter away from that. So let's take first 1/10 of a millimeter. And this is, I want to see what kind of finish we are getting. Now I speed it really up and let's see. Well, it doesn't look good, but it feels good. Well, now it should be 20, let me guess, 21.95. 94. Missed 1/100 of a millimeter. So now we take 1/10 of a millimeter and it should be there. 1/10 of a millimeter. And well, And still more speed, because this is the finishing pass. And there you are. So we were aiming at 28.5, and let's see where we are actually. Well, 28.84. Well, that's acceptable. And now just do some chamfering here, like that. Then it might work. Yes, works way better. There you are. Oh yeah, and now chamfering down. And now we need to part it. Yeah, there you are. Yeah, and of course we got the major burr in this piece. Huh. That's but well, okay. So, well, now I just deburr this one, that horrible stuff, and clean up the mess, and after that we start putting this in place. Now I have done this little piece of copper, and this is the piece we had. As you notice, it has a lot of slope there, so a lot of play. So we put this there inside, like that. Try not to wrinkle it. There you go. Let's put it all the way in. Oh. Well, of course we need to put this one in advance there. Yeah. So what I did, actually, this shaft was really, the finish was, well, Chinese. It was not good. I have done some emery with that one. Okay. After that, this, and now. It's a really good fit, really good. So it means that that's now okay. Next thing is to put the wheel here, but we cannot put it as this because of this. We should be able to put some copper foil there in between. The gap should be suitable for that one. So let me make the suitable copper strip, and after that we put the wheel on. Okay, now I have done these. The other one is already there. And I also noticed that it's easier to put this one here in advance and then put the whole thing into there. It was almost impossible to put it there, the larger one. It's a little bit tight. Oh yeah, this is a little bit loose. Let's see again if it's better. This is hard already. Okay. Making some progress here. Should go there now, quite. Yeah. Okay, we are there. Are we? Yeah. And this is really straight. Really nice. So, and now we put this on. And then we have this one. Like that. And then we have this, and this was the correct, yeah, this is right hand thread. Well, it's really straight. Good! So, soon we will hear how it sounds. And yes, these don't need to be tightened really hard. And this one is absolutely, I cannot see any wiggle there. It should be straight. Well, I will prove it now. How does it sound? And this one, again, because it's a new wheel, I need to be here on the side, not anywhere here. So let's see. That's perfect. Good. Yeah. I think we have a winner here. So now I'll just next thing I will do, I will put the cover on and then the support on. That's just I'll do that off the camera, and let's see. I will figure out or try this one out. I have one carbide bit to grind. Let's see if it works. At least it looks really straight, and this is nice. And yeah, oh yeah, there is some vibration, but not a lot. Usually you get resonances when this slows down, but now I cannot see any big vibrations there. Okay, so I will now put the covers on, put the rest on there, and after that we'll do one sample grinding with this one. Well, let's see. This is a threading bit I wrecked a while ago in the lathe, and let's see if I can put this into a very decent condition. Okay. So the first one, this is the ruby wheel, and let's see now. Well, there isn't much to do. Just take away some of the material here on the back side. Just nice round, and this is really nice. It doesn't throw away any grinding, just the metal. Okay, and the finish is really decent. Okay, well, there isn't much we can do for that one, so let's go to the other side. That one. This is now the boron nitrate, cubic boron nitrate wheel, and now I will grind the top of this one first. Oh yeah, this works really nice. Ha! Well, this works. Okay, that's it. And now I will just grind the edge, this edge. Oh, there you are. This is fast, actually. Really fast. And no green dust. Haha! Oh yeah, it's there. Well, I will take a close-up photo for you, but this one is now done. It's really fast. Does not vibrate. It's perfect. So, that was the subject of today. So, changing grinding wheels on bench grinder. So, till next time, see you!